All right, ready, Brooklyn?
Sure.
Okay, so the first thing we're going to do is we're going to do the velocity of the y. Okay, we got to do the velocity of the y first, and then we're going to do the velocity of the x. So on the board, do a velocity of the y equals a v and a y of a y equals the velocity sine angle. So that's v, open bracket, sine angle, close bracket. Okay, up at the top, let's do the velocity above that. Velocity equals 55 kilometers per hour. And our angle is 13 degrees. Okay, so now you have your information. How do you do that? You take your 55 kilometers per hour underneath there, 55 kilometers per hour, open bracket, sine 13, close bracket. In your calculator, put that in. Make sure that your calculator is in degree. I almost had it.
12.4. 12.37, but 12.4.
Okay, so let's go ahead and let's say 12.4. Okay, now we're going to do the velocity of x. So underneath there, do velocity of x. We're going to do velocity cosine angle. And then we're going to plug our numbers in again. So we're going to do 55 kilometers per hour. Cosine 13.
$53.6.
Okay. 53.6 kilometers per hour. Now, the y would be going up. So put up beside the 12.4 kilometers per hour up. Yes. Now, the y can either be up or down, correct? All right. And then the x-axis is going to go forward. So put forward. Since these are vectors, we want to make sure we include what direction they're going in. Anybody having question on this problem? Is everybody good? Okay, you'll raise your answer. Now where we're going to go is we're going to go to page 94. So go to page 94.
Oh, no. You want to take it?
No.
Okay.
So what we're going to do is we're going to do question number 2. Okay, Josh, do you feel comfortable, or would you like me to do it?
Can I do it? Will you help?
Sure, going up. Okay, so we're doing question number 2. We're on page 94. A plane travels 2.5 kilometers in an angle of 30 degrees to the ground, and then changes direction and travels 5.2 kilometers with an angle of 22 degrees to the ground. What is the magnitude and direction of the plane's total displacement? So on mine, I did displacement 1 is 22.5 kilometers.
What?
Displacement D1 equals 2.5 kilometers. Angle 1 is 35 degrees. D2 is 52 kilometers. 5.2 kilometers. And angle 2 is 22 degrees. So here we're gonna do our change in X, change in Y. Got it so far?
Miss Owen, I thought you were doing number 2. Yeah, she is, isn't
I am doing number two.
it?
ain't I?
Atlanta.
Are we, yeah, we skip number one. Skip number two.
Yeah, I was about to say.
Is it okay? Are we all good?
No, yeah, I thought.
Okay, cool. So change in X is what we're gonna look at first. Change in X1. That's going to be D1 cosine angle. Okay, so it's 2.5 kilometers. Cosine 35. Put it in your calculator. Yep, 2 point what?
Zero.
All right, so it's 2.0. 04? Yeah, 2.0. Okay, so now we've found change in X. Now we got to find change in Y, right? You just saw her do that. Let's go ahead. Change in Y. Change in Y1. Okay, so that is D1 again. Sine this time. The angle.
So D1, so
I bet he's right.
Four. 1.4?
Yep, 1.4 kilometers.
Because I know people can't see the back, so.
Now what we're going to do is we're going to do the change in X. So underneath there to change in X is going to equal D2 cosine angle 2.
If it changes X, it changes X too.
It's change in X.
Which,
Well, I guess you would be say change in X2. I'm so sorry. Thank you, Hannah. Let's do change in X2. Okay, so now we're going to take 5.2 cosine 22 .
4.8.
Okay. Now we're going to do change in Y2, which is D2 sine O2. Now, if you look on page 93, I'm just going through what they are doing in the example problem. All right, guys?
1.9.
What'd you get?
1.9.
4.9? Or you
1.9.
1.9, yes, perfect. Okay, so the first thing we're wanting to do is we're wanting to find the change in X, change in Y for the first and then for the second. Once we get that done, now we're going to do the change in X total, please, sir. That's going to be, you can go down there. Oh, it's too low for you, isn't it? It's okay. Change in X total. The triangle X TOT equals the change in X1 plus the change in X2. Okay, so our change in X1 is 2.0 kilometers, correct? We're going to add that to 4.8 kilometers. What do we get? 6.8. Yeah. Now we're going to do the change in Y total, please.
Can everybody see that line? I'm just gonna go.
Sounds good. Change in Y total. That's gonna be the change in Y, 1, right? Plus the change in Y, 2. Okay. Change in Y, 1 is 1.4 kilometers. And the change in Y, 2 is 1.9 kilometers. All right, add those together.
3.3.
Okay, 3.3.
Yeah.
Are we good? Is everybody good so far?
Yeah.
Yeah, we can.
Okay, so now what we're gonna do is we're going to do D total. Yeah, we're not even close to done yet. T, and that's why I said I'm doing 2. D total, D-T-O-T, equals the square root, square root,
Oh.
square root, open bracket, change in X total, squared, plus the change in Y total squared. Okay. All right, underneath there, let's put it in there. Okay, so let's do square root. What is our change in X total?
6.8.
6.8, and we're going to square that, right? Plus the change in Y total, 3.3, right? Squared. All right, go ahead.
It'll be right around 58 somewhere.
Shorty pants.
I got 7.5.
No. So not if you're square rooting, it won't be.
Yeah, I got 7.55.
Yeah, I was gonna say if you square root it, it'll be a little lower.
7.55, so we're going to use y'all's rule, 7.5 kilometers. The 5.5?
7.6.
7.55?
You rounded it up to 7.6.
Okay, your rule, 7.6. I'm so sorry. I went the wrong way. All right, so now we got to do one more thing. Are you ready, Josh?
I'm ready.
Okay, the angle total.
What?
And by the way, guys, if y'all don't do an A and you do a circle with a line across it, that would be great.
What?
So what's this below on it?
So I could drive.
Circle with a line across it.
I know, but she asked me.
I know, but everything else is A over there. It's driving me crazy. Equals tan negative 1,
Wait, what?
tan, T-A-N,
Okay.
negative 1, open bracket, the change in Y total over the change in X total. Okay, close bracket. Now, I want to make sure you understand something. You will not have to come up with all those formulas by yourself, okay? I'm going to have everything. Your thing is, can you find the variables? Can you plug and chuck? Everybody crystal clear. Because I know that looks like, oh my God, that's horrendous. But it's not once you start doing it. All right, Josh, what did you get?
Oh.
He was listening. He was listening.
In your calculator, put 10, negative 1, baby. Open bracket, alpha y equal.
Oh, let me find 10. Okay, there it is. Oh, wait, hold on. Hey, whoa, whoa. All right. Oh, why equals.
5.9.
Oh.
Oh my goodness.
I got, there's so much stuff here. I got
3.3 kilometers at the top and 6.8 kilometers at the bottom.
That's what I'm saying.
Yes.
25.88.
Yes.
So 25.
Yes, so I round, can we say we can round it to 26?
26.
Let's jump to 2 spaces.
No, you're right. You're right. You're right. I said it like that, but you're right.
Okay,
If we
and
go-
that is above.
If
We
we
got the
go
direction.
if we go around
What?
to a single digit-
Above, A-B-O-U-B-E.
Literally right above.
Beside the 26. Right the word above.
Oh,
Good.
I didn't.
He's like above.
I was looking like hand sanitizer.
Thank you. Leave it up there right now and have a seat. All right. So let's look at this and let's analyze what we have, okay? So basically, in this word problem,
Everybody, tough
we
it out.
had,
Cancel or something.
sure,
I got your pace stuff, so give me a church.
okay, so we have our displacement and we have the angle for two different types of things, correct? You understand what we're doing here? We have our displacement 1 and our angle 1, and we have our displacement 2 and our angle 2. The first thing we have to do is we have to find our x. Remember, what is our x? Straight across, right? And then we have to find our y. Where's that at? Straight up, above. Everybody good? X, y. So to do that, we have to use our cosine and our sine. We use the same thing, cosine and sine, based on the x and the y axis. And the only thing we're doing here is we're just taking our displacement and our angle, and we're either applying cosine and sine to it. We're doing that for x and y1, x and y2. Once we do those, then we got to find out what is the change in x and what is the change in y. Once we find those, then we can find the displacement total. To be able to find the displacement total, we have to square root those and add them together. Okay? And and then also square them. After we get that done, we have an answer, and once we have that answer, then we can also find our angle. So we're finding x and y for both situations. We're finding what our displacement is, and we're finding out what our angle is with them combined together. Is everybody crystal clear?
Oh, yeah. Perfect, like glass.
Okay.
Looking through a perfectly shined window.
All right. Do you want to do another one?
No. I
Okay.
don't have much, I don't have, yes, I'm saying,
All right. Let's go to section 3 now.
we're in section 3.
We were in section 2. Now we're going to into section 3. Okay.
If you're on page 94, you're in section.
You're exactly right, baby. I'm sorry. I don't even know what I'll argue with you. 99 is where we're at. Is everybody on page 99?
Yeah.
I was going to do the rest of those, and they said no, they didn't want to do another problem.
No, it's fine. It's like you're in section 3 already.
Okay, I'm sorry. It was a personal problem between each other. Okay, so 999. So Autumn, you're next. Come on up.
Oh, yeah. Where you at? There you go. Oh, yeah. I'm gonna show you.
I'll tell you what, I want me out.
You take a nap now?
Yeah, I'm not doing that.
So this is what I asked Josh. Did I not ask? Go ahead. Did I not ask you at the beginning? Do you want me to do it? I can do it.
I'm not, I want to do it, just because I want to ride on the whiteboard.
Yeah, they're right on us. I'll tell you that much.
No, I don't want to see any of those gummy things in my hallway. I had little pieces of gummy things down my hallway yesterday. I don't know where they came
I
from.
want to know to remind me.
Okay, Autumn, race the board, baby.
You know, I ain't the only one that don't go to that other Dollar General. Don't be accusing me now.
Yeah, those are gonna be cheap.
And well, that's because.
Okay, you ready, Autumn? So it says a baseball rolls off a .70 meter high desk and strikes the floor at .25 meters away from the base of the deck. How far was the ball rolling? Are you ready? So the first thing we're going to do is the change in Y.
You got a stool?
Be quiet. Change in Y.
I'll flash it for you.
And it's going to be negative .70 meters. Okay. Our change in X is 0.25 meters. And then our change in Y is going to be gravity, which is 9.8. Put 9.8 in gravity for acceleration. I'm doing acceleration. Those of you in the back, get your stuff together, stack your stuff up, and then come up here. We're not going to. Page on 9. Okay, so you ready, man? 9.8 meters per second. So our change in Y is gravity. Okay, that's what we're doing. So we're going to do change in T. equals the square root of 2 times the change in y over a y. Excuse me, just a. Excuse me. Equals the change in x over vx. We're going through a process right now. Okay. So first of all, what we have is we have 2 scenarios that we could use. Okay, baby? We could either use the one on the left-hand side or we could use the one on the right-hand side. We're going to use the one on the left-hand side. Are you ready? Okay. We're going to change it. We're going to do Vx
Oh, yeah, I'm in.
equals square root of a over 2 times the square, the change in y. Okay, so now, do we have all those variables?
All
A.
was on the right, yeah.
We got everything we need so far, right?
Sure.
Okay, so let's do square root. Negative 9.81 meters per second squared. Over 2 times negative 70 meters times 2.25. See what we got. I gotta check mine. That didn't make sense to me at the very end.
Never gonna give you up. Never gonna be fair.
Okay, what did you get?
Negative 8.9.
Hold up. Why did they not really?
Because there's a negative in the square root on the top. You have to take the negative out.
That's lame.
I gotta do it by myself. What'd you get, Autumn?
Negative 8.9.
I got a different number. Somebody else do this problem so we can see what the answer you got is.
Negative 8.9. Are you in degree mode with this
I'm
one?
pretty sure she didn't give her a six.
I am. I did check that.
It actually doesn't matter if you're in degree mode because
I know.
it's not gonna use anything.
What am I doing different than
It
yours?
always matters.
Oh, I'm so sorry.
Yeah, this.
I got you.
Oh.
I'm so sorry.
So
Square
it's on
root
the
on the
outside.
The square root's on the outside, guys.
It's on
I'm so
square root.
sorry. Okay.
Oh my god, I did it again. These calculators aren't made for fat fingers.
Really, bro. I had to let them draw me.
What did you get?
You have to take the point.
This seems like a lot of calculations. Oh, okay.
5.3.
Yes.
5.3.
Yes. Yes. That's what I got too.
You got 2 decimal places here.
No, but you got to round to 5.3
It's meters
because
per
it's
second.
6 figures.
Yes. So everybody good with 5.3 meters per second? All right. Go ahead and get up and go to your station to go find your thing. Like I said, this is a hard. It gets easy after this. Just this.
I'm just saying.
Thank you so much. I appreciate that. All right. So, Elena,
Yes.
I don't think I can't hear you, so we're gonna do the little texting thing again. So, can I meet with you at, Can we say 2:45 today? If you'll text it in the comment box. Oh, you even show me your picture. Fantastic. So what I want to do is I'm going to put an announcement online under the comments for the people that are at home. I want to meet with everybody at 2:45. I did put your test grade in for your test today. You should have saw that. You should have got it. So what I'm doing is I am printing out your test. But anyway, it doesn't matter. I will talk to you after school today at 2:45. Okay, baby? All right. Thank you for coming. Have a good day.